I'm Jo Coleman and I'm the Strategy Director at the ETI. The UK can afford a transition to a low carbon system. Our modelling and analysis work shows that probably costs in the region of 1 to 2% of GDP between now and 2050. At the lower end of that, if we invest in the right technologies and integrating them into the system from today. Over the next 10 years, we need to focus our resources on developing and improving a basket of technologies, and we need to focus on the technologies that are likely to be most at play in 2025. We need to not just prove the technologies, but we need to prove the business models, the operation of those technologies, the regulatory systems, the policy, and we need to develop the democratic legitimacy that will allow decision makers to make decisions with confidence, whether that is at national level, regional level, or local level, or indeed individual consumers and householders. But they need to have the confidence that they can make decisions around what technologies to apply in their own area. When we think about the way we transition the UK, it's important we think about the whole energy system. So we think about the integration of power, heat, transport, industry and the infrastructure that connects them. But we do have a great opportunity ahead of us, and part of that is because a lot of our infrastructure and our assets are ageing anyway and need to be replaced. So we have a choice about whether or not we replace them with similar assets to those we use today, or whether or not we replace them with low carbon assets. But because they have to be replaced anyway, the cost associated with low carbon is only incremental cost, not the absolute cost of the deployment of those technologies. We also have a great opportunity in our resource base in the UK. We have ample storage facility under the North Sea in both oil and gas reservoirs and saline aquifers to store carbon that we can capture from our power stations. We also have a great resource in our offshore wind. We have sufficient land available to be able to grow our own bioenergy so that we can be confident of the sustainability of our bioenergy without impacting on our food production in the UK. There are many challenges involved in the transition, but probably one of the biggest ones is the way in which we heat our homes. Around 90% of the homes that we'll be using in 2050 already exist today, and they're generally very inefficient. So we need to be able to focus on efficiency of buildings. We need to focus on how we heat our buildings and bring in low carbon sources. We also need to look at the way we integrate those technologies into the home, so the home energy management systems, the way in which we control and use heat in our home is also incredibly important. Carbon capture and storage is important because it can do many things, not just in the power sector. Carbon capture and storage can supply flexible power. One of the things people often don't realise is that one of the key things we can do with carbon capture and storage combined with bioenergy is to generate negative emissions. And by this we mean that growing bioenergy crops captures CO2 from the air, which is stored in the crop. If the crop is then burnt, it's released to the air. But if we capture that CO2 and store it underground, we're effectively removing CO2 from the atmosphere. If either bioenergy or carbon capture and storage are not used in the energy system, then the cost of our transition to a low carbon system will more than double, and that takes it from around 1% of GDP to over 2% of GDP. To put this in context, that's about £200 billion between now and 2050 of additional costs that will have to be spent if we don't deploy either bioenergy or carbon capture and storage. For the next decade, we think the focus should be on preparing for mass-scale deployment of these technologies. So not necessarily going ahead with mass-scale deployment, but doing all the demonstration, the development, the testing and the proving of the technologies so that we're ready to make some key decisions in the mid-2020s about what the technologies will be that are at the core of our transition planning. For example, in nuclear, that involves building 2 or 3 nuclear plants. In carbon capture and storage, It means not just doing the 2 projects that are part of the debt commercialisation programme today, but it means moving ahead with further appraisal of probably 7 or 8 new storage sites, plus 2 or 3 more capture plants, leading to around 2 to 3 gigawatts of capacity available by the mid-2020s. If we do this, we've then built the knowledge and the understanding of how we integrate these technologies in order to give confidence to investors and decision makers that they can move ahead with some of the bigger scale investments that need to happen after the mid-2020s. This doesn't have to cost us a huge amount between now and 2025. If we focus the money that we have allocated through things like the levy control framework and other sources of funding, if we focus them on the technologies that are likely to be key to the transition beyond 2025, there's probably enough money available in order to do this.